Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help with finding the sum of a geometric sequence, and we're going to be looking at infinite geometric sequences where n is basically infinity, which is cool, huh? Alright, so for starters, geometric sequences are sequences that can be written like this, starting at n equals 1. So a sub n is equal to some sort of a1 r to the n minus 1. And the first thing to realize here is that if r, and I'm just going to say the absolute value of r, is bigger than 1, this sequence, this sum won't have an end to it. It'll just go on forever and ever and ever and ever and ever. And get bigger and bigger and bigger and bigger, because the r values, you're going to be adding something like 2 plus 3 plus 5 or something like that. This thing, the sum of a sequence like this, will only have a finite, or will only have an answer when the absolute value of r is strictly less than 1. Equals 1 doesn't cut it either, because if I had a 1 here, you'd be adding a1 plus a1 plus a1 plus a1 plus a1 forever. And there's no answer to that. You end up with infinity. So again, we're looking at sequences here where the absolute value of r is strictly less than 1. All right, so I got a couple examples that we're looking at here. The sequence described by 1/2 plus 1/4 plus 1/8, and this dot 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 means it's going on forever. I'm going to go ahead and write a value out for the nth term. So the nth term is going to equal the a1 term times some sort of r to the n minus 1. The r you can get by taking, again, the ratio of like this divided by this. And if we do that, we get 1/2. And again, I also could have took 1/8 divided by 1/4 and so forth. All right, so now I'm going to go ahead and give this a name. This is now called a series. I'm going to call it s sub n equals. Now, we're looking for an infinite series, so that means that n is infinity in theory, but humor me, for now I'm just going to leave it as n, and we'll deal with that kind of right at the end of the problem here. I'm going to use those standard rules that I've been using to calculate these things. First thing we're going to do is we're going to multiply both sides of this equation by r, which is 1/2. So we're now going to have s sub n over 2 is equal to 1/4 plus 1/8 plus, that's going to go on till the last term. Multiplying that last guy by 1/2 is going to give us 1/2 to the n here. Next term, we're going to take equation 1, subtract equation 2. So when we take this minus this, we now have minus 1/2 times s sub n equals 1/2 minus nothing, 1/2, we're good. 1/4 minus 1/4 is 0. I call those zero pairs or something like that. 1/8 minus 1/8, another 0. And this is going to go on forever. This term here, and there's going to be one right before this that'll subtract. So we'll have a 0. And then the very last subtraction, though, there's nothing here, minus this. All right. I think I'm going to have to take this other example and make myself some more room. We'll put that down there, bring it back when we need it. All right, let's clean this thing up. And when I clean it up here, I think what I'll just do is multiply everything right now by -2, so that this is now just s sub n equals, and that's going to be a -1. All zeros. When we multiply that by -2, we're just going to have 1/2 to the n. All right, so now we can get the sum for any value of n. Now, the class I'm making this for is a college algebra class, so I'm going to stay away from calculus types of talks. But this 1/2 to the n, when you look at some values here, like if you were to put in, say, n equals 100, this would be 1/2 to the 100th power. Or if you put in n equals 1,000, this is now 1/2 to the 1,000th power. For all practical purposes, these are 0. So this term right here for very, 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 very large values of n is approximately 0, so our sum here is equal to -1. We're going to call that done. Move on to the next one. Going to need some room here. All right, so we've got another sequence. Right? And again, I recognize it as a geometric series. or sequence, divide by 2, divide by 2. The next one, I'm sorry, divide by negative 2, divide by negative 2. Next one would be minus 1/2. So our series here, S sub n, is going to equal 4 plus a negative 2. I'll go ahead and put one more, plus 1/2, plus, okay. And that very last term is going to be an a sub n term, and that thing is going to equal our a1 term times r to the n minus 1. The r you get, you can take like this, divide by this, or you can take this one, divide by this one, doesn't matter which, and you get minus 1/2. All right, so there is a our series written out. All right, series is a sum of a sequence. Right now we're going to use this guy. Multiply both sides by r, so this is going to be minus 1/2 times S sub n equals. Let's see, that's going to become a minus 2. Multiply this by minus 1/2, that's going to be a plus, whoops, make sure that this thing worked. 4, oh, we're going to take that one and divide by minus 2. Yeah, that's going to give us a plus 1, so forth. We're going to have these, what I would call subtraction partners here. Well, actually, let me get this all written out here. Let's see, I was dividing by, kind of forgot what I was doing here. Oh, multiplying by 1/2. So yeah, this guy divided by 1/2 is this guy divided by 1/2 is this, and so forth. Next term would be minus 1/4. The very last term, when we take this, multiply it by minus 1/2. This is now going to read, let's see, minus 2 times minus 1/2 to the n to the n. Whoops. Apologies here. I did that one wrong too. All right, when we take this and hit it with a minus 1/2, we're just going to leave that 4 in front, and when we hit this with a minus 1/2, we're going to have minus 1/2 to the n, because anything to the n minus 1 times the anything is the anything to the n. All right, now we're going to do equation 1 minus equation 2. So when we take this minus this, we're going to have 3/2 S sub n. Because when you take 1 minus a minus 1/2, you now have 1 plus 1/2 equals right hand side 4 minus, there's not a corresponding term, negative 2 minus a minus 2. Yeah, I think I was a little bit looking at that thing earlier going, this does not look right, and that's because I missed a term here. That was supposed to be take this divided by minus 1/2, that's a 1, and then so forth. So subtraction partners, we get another 0 there. The zeros are going to go on and on and on and on until we get to this, let's see, this one's going to have 1, this one will not. That last term is going to be minus 4 times minus 1/2 to the n. All right, so 3/2 times our sum is going to equal 4 minus 4 times minus 1/2 to the n. All right, now if I had a value of n, I'd put it in, just calculate a number. We don't. We're looking at where we're trying to figure out what happens when n goes to infinity. Now we've got to take a look at this minus 1/2 here. If we take minus 1/2 to the n, and you look at a large value of n, say 1,000, it includes the minus sign. Minus 1 to the 1,000 is plus 1. But the big thing is that 1 over 2 to the 1,000th power here. This is approximately basically 0 for all practical purposes. Put approximately 0. We don't need to worry about this term. It's gone. So the S sub n we can get just by multiplying by 2/3. So we're going to get 8/3 out of that. And I think I'm going to just call that one done. All right. I hope this helps with how to find the sum of an infinite series or sequence. Have a great day.